This conference will now be recorded.
Hello, everyone. Jordan Girth here with the NESDIS Office of System Architecture and Engineering. Yes, I'm back for one day only, previously with the National Weather Service Office of Observations. Welcome to the Satellite Book Club Seminar Series. This is session number 219. Today's presentation is a GOES view of 2024 and a glimpse into 2025. I'm very pleased to have Tim Schmit with us, a meteorologist from NESDIS STAR. This is a particularly momentous presentation because Tim Schmit is wrapping up an enviable and admirable career in NOAA as a scientist and someone who has certainly made an impact bringing GOES data to scientists and to meteorologists and conducting many informative studies. So we're very thankful to Tim, known on X or previously Twitter as GOES Guy, has shared a lot of great examples of GOES throughout his career. Really appreciate it, and of course, wish him well in retirement. Our facilitator is Doug Kahn, not so close to retiring, a meteorologist from the National Weather Service Forecast Office in Cleveland, Ohio. He'll be leading the discussion and wrapping up today's Satellite Book Club. Just a few reminders, as you heard, this session is being recorded. Please mute your microphones and turn off your webcam if you're not presenting or asking a question. There will be Q&A after the presentation. I encourage attendees to post their questions in the chat, and I will field them, and Doug will field them in the order they are asked. If you are logged in under an alias account, please sign in with your full name or specify your name when asking a question in the chat so we can follow up. We're always looking for future presenters. Please contact our TowerS team if you're interested in presenting, and there should be a link from Emily there in the chat. And the training team can help create training materials that may be unavailable. Ross Van Til can help on that one. I would like to thank the Office of the Chief Learning Officer, the GEO and LEO programs, all of you for being with us. Kashad, Emily from the TowerS team, our facilitator, everyone. Happy holidays and thanks for being with us today. Without further ado, let me just give a little more background on Tim. Tim currently works at the Advanced Satellite Products Branch, ASPB, within the NESDIS Center of Satellite Applications and Research located in Madison. Actually, I thought the ASPB went away. So previously worked at the Advanced Satellite Products Branch. Tim had a lead role in the band selection for ABI on GOES-R. As I had mentioned, Tim has played a key science role during the on-orbit checkout of GOES-8 all the way through 19. Tim has published over 100 journal articles, several book chapters, and co-edited a book. I was looking for it here on my desk. It's just out of reach. Tim received, all associated with some aspect of GOES, Tim received his master's degree from the University of Wisconsin-Madison. And Tim is a repeat presenter at the Satellite Book Club. And I believe this is your 6th time at the book club, in fact. So one of our Satellite Book Club all-stars. So you're in for a treat today. Thank you so much, Tim, for being with us. I hope you're looking forward to a good retirement, but let's get this presentation underway.
All right. Thank you so much. Yes, now I'm with the Sensors and Calibration Branch, but still within NOAA NESDIS STAR. So, yeah, thank you all for your time here. We can actually go on to the second slide and get started. So, basically, you know, this is going to be a glimpse back, and then we're going to go way back. And there you go, 2024, and then a bit glimpse to the future. And when I mean way back, I mean even before GOES. So the ATS NASA satellites. If you go to the next slide, so these were the precursors to GOES, and we just recently celebrated the anniversary of the launch of ATS-1, December 6, 1966. And then the first image you can see there, December 11th. So this is what all the GOES images can be brought back to, this first visible image, where, as Vern Sumi said, the weather moves, not the satellite. Next slide. You can also see how they used to get a little bit more fancy than we did. All right, so they didn't rest. 1 year later, ATS-3 now had 3 visible bands, red, green, and blue. And if you recall your cover of BAMS there from 1968, there was the nice true color from ATS-3. So it wasn't, of course, it wasn't going to be again for decades later over us. Next slide. So, I like to break things up as kind of the first of their kind, and that's what ATS-1 was in 1966. First operational. Next year, we'll celebrate the 50th anniversary of the GOES-A launch, which became GOES-1 in October of 1975. Of course, that went with 1 visible and 1 infrared band. And then whenever you get orders of magnitude improvements. And of course, that's the GOES-R series, GOES-R ABI, as we used to say, better, 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 spatial, spectral, temporal. Next slide. So, there are a lot of loops to choose from. I've tried to take my favorite one from each month of the year. Here's the cloud phase distinction, RGB, from the ABI along Lake Michigan. A couple things remarkable about this presentation. You can see the vortices there and how they're lined up there. But this was also very well forecast. That same structure was forecast by some of the mesoscale models ahead of time. And of course, radar was also showing it. I like to say those were both verified by satellite, but still a remarkable case. And of course, leading to some snow event in the southern part of the lake there. I'll also say each of these months also have a corresponding Sim satellite blog, and that's what's down at the bottom there. So, for example, follow that link. You can find more about this situation, either other imagery or data from other sensors as well. So that was January, cloud phase distinction, Lake Michigan. Next slide. The Smokehouse Creek fire in the Texas Panhandle. So now we're looking at the fire temperature RGB. So obviously using the fire band or the 3.9, but also the 2.2, which also has sensitivities of fire, as well as the 1.6. So the hotter the fire, you go into the reds and into even hotter in yellows. So you can see why we need GOES with the, how rapidly these fires are changing. Not, at early in the loop, you can see they're moving basically to the east. And then as the front wind shift comes through, you see then they start moving or growing to the south. So just another reason why you need the rapid scan that the ABI provides. Next slide. So we often think of the eclipse time from the satellite perspective, i.e., especially in the GOES 8 through 15, or even before that, we wouldn't get data for hours when the satellite was eclipsed by the Earth from the sun, because we weren't getting enough solar power to operate this. Well, here's almost the opposite. So this is the SUVI, solar UV imager, from GOES 16, looking at the sun in one of its 6 spectral bands. But then you can see as it fades to black there, it's basically being eclipsed by the Earth. So there's a little bit of brain 3D-ness here. And obviously the SUVI data is also sent out as part of GRB and used for space weather. All right, next slide. April wasn't going to be an easy one. It had to be something about the eclipse. I think I put this request in for a research meso to follow the main shadow somewhat like 18 months before launch. What we're looking at here is a composite of those 1-minute mesos plus the 5-minute conus plus the 10-minute full discs. So you can kind of see the blocky area there. Let's see, where the meso is. This is band 3, but it's highly enhanced to really bring out that umbra, the darkest part of the shadow. So you can not only see it as it as it moves, and again, there's also if again, as you follow this link, I also put the track on it to prove that the shadow and the forecast track lined up. So obviously, very interesting case of an experiment being able to turn the sun off for some time to see how the atmosphere would respond. Go to the next slide. So here's nighttime microphysics, RGB. So again, split window difference, 10 and 12 micron. Talk about low level moisture of 11 and 4 micron, and then just the clean IR window combined. So the thickest clouds here are in the red. But what you can see here as the storm moves away in the panhandle, that line that goes kind of northwest to southeast, and that's evidence of hail swath over the panhandle. We also saw this, for example, in the like when we looked at the land surface temperature product, you could see how much cooler that area was because it didn't heat up as much because of a large amount of hail. So again, it's ABI not just only to look at the clouds and then the convection, but being able to see the wake of the hail as the clouds moved off. All right, so let's move on to the next month, if you will. That was May. June, we're over parts of New Mexico and Mexico. First start out with the SIMS true color imagery, and then we fade to the dust RGB. Dust RGB uses a number of infrared bands as well, including the 8.4 micron band and 10 micron, and I think the 12 micron as well. So you can just see the dust front there, originally kind of in the visible, that kind of the gray. You can see obviously the convectively induced dust front as it moves to the west, but then it moves into kind of this pink as we move on. So I think maybe we've done one part, which observe this from space. I think maybe the harder part is make sure that everybody gets notified when this is coming, as they come so rapidly. You can also see a fire in the northwest corner there. All right, if we go on to the next month. Of course, I need to show a number of hurricane cases. I try not to show just hurricane cases because sometimes I get the feel that people think we just turn our goes on only when they're hurricanes. It's like, no, we look at a lot of other things too. So straight IR clean window, 10.3 micron, where the colder clouds are red, getting into the blacks and even the whites. So obviously you can see the eye, the advection, the convective bands as they rotate around. And this is when the hurricane was around a Cat 5. Next slide. So, obviously, GOES can see the most extremes, F5, at least the convective storms associated with big outbreaks, but also is always monitoring for these weaker events as well. So what we're looking at here, cloud phase distinction. So you're looking at when the cloud glaciates from water to ice as it goes from basically the green to the yellow color there. So you can see the near Buffalo, New York there, kind of a convergence line with some of the lake breezes. And there is, I think, I don't know if it's a F0 or F1, but a weak tornado at this time over Buffalo, New York. Next slide. Then, of course, we got into, I guess, my favorite part of the year, getting data from GOES-U was launched in June, and it became 19 when it got to its geostationary perspective. And now it's at approximately 90 west, and it's still in its on-orbit checkout. So we're just looking at the 16 bands of the ABI here, preliminary, non-operational, of course. And this is in September, so just before one of the reviews there. So you can see the bands 1 and 2, the 2 visible bands, the 4 near IR, or we like to think of them as near visible, since they are mostly a reflected component, and then the 10 IR bands from the 3.9, 3 water vapors, and the number of window channels, and then with the ozone and the 13.3 band 16 lower right. Go on to the next slide. Couldn't just pick one GOES 19 loop. So here is a case of another shadow, moon shadow falling on the Earth. This happened to be again in the southern hemisphere, of course, with a 10 minutes cadence. Go on to the next slide. So this is actually in November loop, but you say, hey, it's in October. Well, it's about a 10-day or loop here of the volcano in near Mexico City. Ash, RGB, where the ash is that kind of fuchsia color. Of course, there are also derived products, Volcat for used in the vacs, etc. But this does show how much it can change over a short amount of time. At some point, well, this loop doesn't show it here. I'm getting up over southern Texas. Obviously, there's flight issues as well with this. Anyways, again, this is from GOES 19, preliminary, non-operational. Next slide. A little bit subtle there, but yeah, thanks for pointing that out here. So this is a cloud distinction. And basically there was a power plant, Menominee, Wisconsin, that was seeding, if you will, the cloud deck. And that the darker color there is where we had some light snow, although it added up to maybe 1 or 2 inches in some locations. I think it was a surprise to some drivers. I think there was a crash. I think they had to shut down one of the highways. So again, I think sometimes these more subtle events can just have impact, again, if people aren't expecting them or don't take the right precautions. So also, yeah, so this is the day cloud phase distinction during the day, and then it gets in right as sunrise into the more true color. And again, there's more information out there on the web. All right, next slide. All right, so this loop starts in June, but it ends in December, so that's why I could count this as, and as someone said, but December is not over yet. How can you give this talk? Well, you're right, things might still happen. Obviously, we have, this shows the GOES east and the west perspective, showing that we get, from the coast of Africa to the coast of Australia, which is pretty remarkable when you put the two. This is just showing every hour data. there are links below of places where we routinely generate this. But again, this can really show the heartbeat, if you will, of the planet. Next slide. So just since I have everybody's attention, remember Bill Line's Satellite Book Club on maybe, I think, the best of both worlds, where you get to look at the RGB imagery, but then you can get readouts from derived products. Go on to the next slide. So instead of trying to deal with a pretty messy 4-panel that is shown on the left there, where, you know, there's not only an RGB shown, but also, you know, some of the derived products. On the right there is shown, and again, if you have your right RPM, you can find this, I think, under local menus. So again, looking at the RGB, but then you turn the readout on, and you can get an idea of the optical depth, the cloud height, the cloud phase, etc. So again, especially maybe if you're newer to this and you're like, boy, the RGB just changed from yellow to red. Did the cloud really change? Well, that may have changed just with sun illumination. But again, you can verify with the level 2 product. Or again, if you're looking at a dust RGB and you say, well, is that pink or is that fuchsia? Is that really dust? Again, you can tip and verify that with the RGB or with the derived products. There's a number of combinations, be it associated with moisture, clouds, aerosols, etc. There. Go on to the next slide. So a lot of things to look forward to. In April, GOES 19 will slated to become the operational east, as GOES 16 will move to 105 and be in storage then. So here's just the image is just the 16 spectral bands of GOES 19 with, I guess, 8 of my favorite RGBs as well. So you know, that's obviously one thing to look forward in 2025. Going to the next slide. Looking, you know, I said we're going to look back and look forward, and this one slide does that. So starting with ATS and the ATS series in starting in 1966 with, you know, either 1 visible band or 3 visible bands. If you look at, you know, around the 6.7 micron, you can see when my career started, we had 14 kilometer data, then we got 8 kilometer data, 4 kilometer data, now we have 2 kilometer data, and just wait, GXI, almost 1 kilometer data, at least for us, some of those bands, including a 250 meter visible band. If you go on to the next slide, we also have sounders, give us profiles of the atmosphere. It started experimentally, but low spectral resolution on GOES 4. We went operational on GOES 8 through 15. That's great, but that was low spectral resolution. Looking forward to the GXS on the GOXO coming, which will, you know, not have the 8, or it won't have, you know, the 12 bands or 18 bands of the previous GOES sounders, but we'll have 2,500 spectral bands to give us more vertical resolution. So looking forward to that. Go on to the next slide. So one of the examples here, this is all simulated data, of course, but if you look at the temperature and moisture profile, you can see the, you know, inversion dissipate there. But if you just had nothing but the spectra and you looked at that, you could see how these absorption features are now warming with height instead of normally cooling with height. So just looking at how those spectra change, you can get an idea of how an inversion is changing over time. And looking forward to that and a lot more from GXS. Go on to the next slide. Yeah, I think blogs can be a great resource for kind of a just-in-time training. List 2 here, the Sim Satellite blog and the satellite liaison blog, mostly filled by Bill Line. Of course, the ABIs, measure a range of phenomena over a wide range of time scales, from the, half a kilometer, 30 seconds, to the planetary wave scale. As I mentioned, looking forward to GOES 19. 2025 will be the 50th anniversary of the GOES launch. 2026 will be the 60th anniversary of ATS 1 launch. Of course, looking forward to the whole GeoXO program, imager, lightning mapper, sounder, air quality, etc. So a number of the examples I showed were in Sim's satellite blog. That was kind of a review of 2024. If you go on to the next slide. So again, this is kind of my career, starting with GOES 7 there in 1987. But yeah, thanks to Jordan Girth for starting the Satellite Book Club, and thank you many for keeping it going. I know starting things are hard. I know keeping things going are even harder. Thank you all for your time, and I can just say it's been an honor to work with all of you, and I appreciate your service. So thank you very much.
All right. Thank you for the great presentation, Tim, and we wish you well in retirement. Congratulations.
Thank you.
So as always, we encourage attendees to please stay on for the discussion, particularly those from field forecast offices and regional headquarters. We also ask that everyone change their views to active cameras from the default view, and this can be found at the top of the GoToWebinar software GUI. If you and the speaker decide both to use your webcams during the ensuing discussions. And then we also remind attendees to please submit their questions via the chat feature. Emily Maddox has posted, I believe at the top here, or here we go. Emily Maddox has posted in the chat a feedback form for this session and any other Satellite Book Club sessions via short survey form. All right. In 3 weeks from today, on Thursday, January 9th at 12 p.m. Eastern Time, Kevin Thiel, research meteorologist from CIRO and the GOES-R satellite liaison to NOAA's HWT Hazardous Weather Testbed and Storm Prediction Center, will summarize the 2024 Hazardous Weather Testbed. I also want to note that today will be the last day, last Satellite Book Club of the year, and we are looking forward to this talk being the first Satellite Book Club session of 2025. And as always, please contact the Tower S team, Kashad Bowman and Emily Maddox, for questions about the Satellite Book Club or for configuration of satellite products. All right, and then with that, we will get into the discussion. So I see there are already a few audience comments and questions, so we'll start there. We'll start with Dan Lindsay. So, let's see, Tim, Andy H. is fairly recently seeking the spectral response functions for the early GOES imagers. Do you know if anyone was able to unearth those?
Yeah, yes and no. I believe Matt Gunshore put a link in the blog where some of them are posted. So SMS, we were able to get those spectral response functions. The GOES 1, 2, and 3, we basically got one set that said, these are from GOES, but didn't specify which of those, GOES 1, 2, or 3. And I think that's the best we can do. Of course, we have them all for GOES 4 and beyond, imagers and sounders. So I think that's about the best we're going to have, unless somebody dusts something off from Santa Barbara Research Center data book from 1978 for goes to.
All right, thanks for the response. I see Matt also posts, like you said, he posted a couple links in the chat there for those looking for additional information. I do have a couple questions here. So my first one is really talking about GOES, but also talking about the polar orbiters. And will there always be a place, do you think, for polar orbiter sounders, or do you believe that eventually the geostationary satellites will have the capability to eventually overtake this main role for in a forecasting sense?
Yeah. I mean, I know we certainly need two wings to fly now, and I think that's going to be the case in the future as well. Of course, LEO by polar orbiters by their definition fly over the poles. Goes by the geometry is never going to see a good view of the poles. So I think we just need to have the right balance of microwave, do what it can do for a polar orbiter. I think there's a lot of interesting work with maybe swarms of satellites in the microwave. But I think the geo, especially using one instrument, looking through the same atmosphere at the same angle. So when you see small changes, that that's something real. Where if you're trying to put together too many, then you bring in parallax. Is it a calibration issue? Is there dust in the slant paths? But I think we're going to need both LEO and GEO for a long time.
Yeah, that definitely makes sense. I do have a follow-up question to that as well. In addition to some of the sounding information being included on this next generation of GOES satellites, do you see that additional information being implemented more and more into data analysis tools such as the SBC mesoanalysis in the future?
Yeah, I really do. I mean, there's the how much information, how much radiance information can really be assimilated into an operational model, and there's timing issues and whatever, and like I say, now when you're at 2,500 channels, and the way you really get better vertical use information is to use a lot of them, not just use just a few of them. So I think there's the case obviously for putting as much information we can in models, but as far as at the WFO level, SBC mesoanalysis, to be able to understand low level moisture pooling, the vertical theta E, even just being able to modify or monitor how good models are handling the situation upstream.
Absolutely. And my last question here, actually, someone just put in the chat as well. So I'll take Dave's question here. Great loops, Tim. Thanks. Was one of your favorite GOES animation, or what was one of your favorite GOES animations of all time in your career?
Okay.
Or at least one of them.
Yeah. Okay. I guess I'll let me give two examples. I can't just think of one. So when I started working on ABI, it was 2019, and launch was going to be 2008, and it was 10 and 12 and 15 and 16. All that time, I told everybody, ABI is going to be great. It's going to be wonderful. It's going to be amazing. And when I saw that first visible image, my first thought I had, and I've never told anyone this, my first thought was, am I looking at MODIS? I mean, it was that good. It was that clear, and that's good. But that was just a still image, so I get to answer it the second way. So here it was, 2016. GOES R is waiting at Cape Canaveral to be launched, and so I was very interested. There was a hurricane loop, a Hurricane Matthew, as it moved its way up the east. The forecast for it was for it to keep offshore, so the worst of it would be off, and there would only be minor issues, and that's what happened. But obviously, that was one of my most interested loops for. But I know GOES 12, Katrina is pretty amazing. GOES 9 when it was over in with Japan, and there was a year of some pretty active super typhoons. So I can't just pick one, but that's one of the links that Matt put in there was one of my favorite loops from each of the GOES 1 through 19.
Yep, I see that link in there. Thanks,
Yeah.
Matt. All right, well let's see. Those are my questions here. Oh, looks like another chat we have from Chris. Just commenting that your work has truly advanced the science of meteorology and left a lasting mark. And congratulations on your retirement.
Okay. Thank you. Yeah, very kind words. Yeah. Okay. Scott Lindstrom corrected me on what my favorite loop should have been. um, when before we launched ABI, we knew we were going to have this 1 minute data, but obviously there wasn't a lot of operational use of to be able to do that. So in 2012, we asked NESDIS operations, hey, can we take GOES 14 is going to be out of storage anyways? It was can we take and do some special 1 minute data, super rapid scan for GOES R? To my surprise, yes, sure you can. I got to be the final, I guess, decider where we moved around. My goal was to make sure nobody got too happy. Obviously, the hurricane guys want to look at hurricanes, and the fire guys want to look at the fire guys and convections and whatever. But anyways, it was about to be turned off, and a colleague says there's going to be an epic storm, maybe affecting New York. You got to leave it back on. I said, can I leave it back on? They said, sure. We gave them the center points, and we got 1 minute data of Superstorm Sandy for the 6 days before it made landfall. So thank you, Scott, for that correction. But then we got 1 minute data for parts of 2012, 13, 14, 15, and 16. So then when we got ABI data with 1 minute, it was more hit the ground running. We know how to take that data and move it into information.
Excellent.
I guess since I have there's a collage up here, I've had too many highlights to say, but as a meteorologist, when you get flown down to Atlanta and you can be on a show that's called The Weather Geeks, I mean, I tell you that's right up there. I also have the cover of that BAMS article on the ABI, but mostly it was being able to talk to forecasters and users and get everybody ready for the better ABI.
Well, we're us in the operational field are all looking forward to the next generation of GOES satellites and how we can implement that into operations and forecasting. So we truly thank you for your work.
Yeah.
So unless you have anything additional to add, Tim, I don't
No.
see any more comments
No.
here.
Yeah. No, just thanks everyone for your time today. Thank you for the comments in the chat. I will leave federal government, but I'll still be around as a honorary fellow at the University of Wisconsin. So feel free to send me a GOES question or comment. I just may not respond as quickly as I have.
All right. Well, we really appreciate it. Yeah, so Tim, thank you for presenting at the Satellite Book Club today, as well as all of your contributions to the Satellite Book Club and satellite meteorology over the years. So congratulations on your retirement. You will be missed and always welcome back to present at a future book club.
All right. Thank you.
All right, so thank you everyone for your attendance today. And as previously mentioned, please remember in 3 weeks from today, after the new year, the first Satellite Book Club of 2025, Kevin Thiel, research meteorologist from CIRO, and the GOES R satellite liaison to NOAA's Hazardous Weather Testbed and the Storm Prediction Center, which he will summarize the 2024 Hazardous Weather Testbed. All right, thank you everyone for joining us today. And please remember to contact the TowerS team if you have any additional questions. Thank you, everyone.